Unit 3, Part 7. Let's do some exercises from the back. So for all these questions, A, B, and C are assigned the truth value true. X, Y, and Z are false. G, H, and I are unknown truth values, okay? And you're to say whether this is for question 3, I think. Can you figure out the truth values of the following? Why or why not? It's question 3. So these are the exercises. Do a few of these. You really must do these ones. This is now unit 3, and from now on, it's very, very crucial you do a lot of exercises to hammer home your understanding of the material. And doing these exercises, these ones here at the end of unit 3, are very good for setting in your knowledge of the truth tables that you're taught in this chapter. Okay, and you really need to know it, and you need to be able to apply it quickly, especially in the exams where you have a time limit and so on. Okay, so we'll just go through them so you see how you do them. So 1E here, you've got not B, hook, not brackets X or Y. Okay, ask yourself what the major operator is. Right, you should learn to be able to see it sort of straight away. But the major operator here is a conditional, right? This is a conditional. It's not B, hook, this. Say what it is. It's a conditional where the antecedent is a negation and the consequent is a negated disjunction. Right? This is a conditional where the consequent is a negated disjunction. Right? This negation, what is the scope of the negation? Klenk teaches you. I talked about scope when I was doing lectures for Unit 2, but it's here in Unit 3. Klenk explains to you what the scope of a negation is. Right? Remember, negation is also a rule, not blank. Replace the blank with some legal formula, any legal formula, and you have a negation. But then what is the legal formula? Whenever you see the negation sign, the question comes up, what is the formula that I'm negating? It's the first legal formula that you come across when you put your hand over here. So open brackets means not till I have a closed brackets do I have a legal formula. So this isn't negation of X, the open bracket, this is the negation of X or Y. Right, the whole thing. Okay, which means I need to determine the truth value of the disjunction to be able to determine the truth value of the negation, because I'm negating the disjunction. So I need to know the thing I'm negating before I can know the negation, right? Here actually, since B is true, right, also I'll be pointing out the shortcuts, right? When you can answer the question, the main question, the actual question, when you can answer it, skipping computing some of the truth tables. Right, again, that's knowing from the truth tables, applying the truth table knowledge to know what suffices for the truth or falsity of a disjunction or a conjunction or a conditional. Right? In this case, B is true, therefore not B is false, so, right, that suffices for telling me that the conditional is true. Right? Oh, I never said this, but this is a crucial thing to keep in mind. Conditionals are always true when the antecedent is false. Right? Conditionals are always true when the antecedent is false. Check the truth table, the third and fourth rows, which have P both being false, right? False, true, and false, false. Both of them turn out to be true. Right? Remember, there are three cases when the conditional is true, only one case when the conditional is false. It's only false when it's T hook F, when it's true hook false, right? But always, you'll be applying these two shortcuts many, many, many times, right? The conditional is always true when the antecedent is false, right? And the conditional is always true when the consequent is true, okay? So you got to remember when it's the antecedent and when it's true or false. Conditional is always true when the antecedent is false. Conditional is always true when the consequent is true. Okay, so here we've got the overall question is, what's the truth value of this conditional? I already know it at this stage, right? Because this conditional has a false antecedent, and I know that false antecedent means the conditional is true. So I can already put true here, right? This false antecedent suffices for the truth of the conditional, right? I can answer that already without having to do this. Let's do it anyway for fun, right? That's false, false. So the wedge is false, right? That's the only condition under which wedges are false, right? Under which disjunctions are false, only when both disjuncts are false. So if that's false and that's true, right? If I hadn't done that first and I calculated that, notice that just knowing, right, question mark hook true, I haven't calculated this truth value yet, but question mark hook true, well, that also suffices for the truth of the conditional, right? Because the second shortcut I mentioned was the conditional is always true and the consequent is true. So the truth of the consequent, right, I could say at this stage, without having done that, here I have a conditional with a true consequent. That suffices for the truth of the conditional. Could put that up right away. All right, look at H. You should see the structure of this in the placement of the parentheses, right? This is a biconditional, but what's the major operator, right? Is it this or this or this? You've got to be able to see it's this, right? This is a biconditional where both sides are themselves biconditionals. It's a biconditional of biconditionals. It's a biconditional where left side is a hook, A biconditional X, right side is B biconditional Y. Okay, now just apply your knowledge of the truth table of biconditionals. They are true when the two sides have the same truth value, and they're false when the two sides have different truth values. Right? The truth table for true, 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 false, false, true, false, false. The truth value for the biconditional is true, false, false, true. True, false, false, true. Okay? So true, biconditional, false is false. Right? I'm doing the components first. I can't do this straight away because I don't know the truth value of this. Right? So this is the truth value, right? Notice of whether that's true or false, right? It's the truth value of this and this, right? The truth values are going to go under the biconditional. It's the truth value of these two complexes. So you are mistaken if you think you could somehow jump to answering this question knowing only the truth values of that and that and that and that. Well, you've got to calculate first the components. It's the biconditional of what? It's the biconditional of A biconditional X and B biconditional Y. So you need to know if A biconditional X is true or false. Okay, it is false. True biconditional false is false. What about this? True biconditional false. Right? True, false. Well, that's false as well. So what is the whole thing? Well, it's false biconditional false. That's true. Same truth value. That's true. Right? Okay, that's the answer to that. All right. Number 2, we have 2D. So G is unknown, right? So what have we got here? Well, what's the overall operator, the overall form? It is a conjunction, right? It's a conjunction of the disjunction of B and G and not A. It's a conjunction of that and not A. Okay, so let's work this out. B is true, G is a question mark. We've not given G. Can we determine the truth value of B or G? Yes, we can. The truth of one disjunct suffices for the truth value of disjunction, so that's true, right? Okay, but not A. A was true, so not A is false, right? Just every step here is just applying the truth tables for these operators, right? When, under which conditions is the conjunction true? It's only true when they're both true, so a false disjunct suffices for the falsity of the overall thing, right? So the answer is false. This formula is false. The sentence is false. Right? I could have done a shortcut. I could have not calculated that. Just calculated that this conjunct is false, not A is false. One false conjunct suffices for the falsity of the conjunction as a whole. Okay?